In this lesson, we're going to talk about determining the point of intersection of two lines with an algebraic method called substitution. Previously, we solved a system of linear equations by graphing. That's what you saw on the previous screen. Today, we're going to solve a system, that means finding its point of intersection, with the method of substitution. Simply defined, this means isolating the easiest possible variable in one equation and subbing it into the other. Let's first review the distributive property. I want to distribute 2 into 3x minus 2. Remember how we do that? We multiply. So 2 times 3 is 6, and then the x gets pushed in there as well. And now 2 times that, that's a negative 2, or subtract 2, or minus 2. That's going to be a 4. So that's a distributive property. These two cannot be collected. 6x minus 4 are not like terms, so we're all done. Next one, I'm going to distribute a negative 4 into the brackets with multiplication. So negative 4 times 3 is negative 12. Remember to start each line with an equal sign. Negative 4 times negative 2y, so negative times a negative makes a positive. 4 times 2 is 8, and then we just have a y. Last one, I'm going to distribute the 3 into, first start with an equal sign, the negative 5x. 3 times negative 5x is negative 15x, and then 3 times negative 1 is negative 3. This piece is not inside the bracket. That plus sign keeps it away, keeps it apart, which means we don't distribute to that plus 4x. That plus 4x is on its own like that. Now we can look for like terms. There are like terms. The negative 15x and the positive 4x are the same. So you have negative 15x's, you add 4 more x's. How many x's have you got? You've got negative 11x minus 3. So that's distributive property. Now we'll do some quick practice for what we want to talk about today. For each of the following systems, remember system means more than one equation, so one equation, two equations. For each of the following systems, circle the one variable that is easiest to isolate out of both equations. So let's just look at this one here. I've got two equations. Here's equation 1 and here's equation 2. Actually, let me just label them. This is equation 1 and this is equation 2. Out of those two, which one has the variable that's easiest to isolate? And that's looking at everything combined. So this y right here is easiest to isolate because in order to isolate y, all I have to do is bring the 7x over and then divide by negative 1. So that's a little easier. Say I were to isolate this 2x, it'd be a little harder because once I bring the 9y over, I have to divide by 2. You can pick whatever out of all these. You've got an x, a y, and x, a y. You've actually got 4 variables here. Well, 4 terms with variables, 3, 4. But the easiest out of all 4 is the y. So we're going to, the question says circle the one variable that is easiest to isolate. So this variable is easiest to isolate. How about part B? So in part B, we've got this equation here and this equation here, and you're looking for the variable that would be easiest to isolate. We're not actually going to isolate it, we're just going to talk about which one's easiest right now. So all of them have a coefficient. Here are my 4 terms that have variables, 1, 2, 3, 4. These are 4 terms that all have variables. The constants don't have variables. So out of those 4, which ones do you think would be easiest to isolate? I think probably this 2x, because it's already on one side by itself. I don't have to move anything to the other side. So all I'm going to have to do here, if I needed to isolate, I would just divide everything by a 2. So it would only require one step, and then x would be isolated. So I'm going to choose this x here. Let me show you what I mean on the other equation. Say I decided to isolate this term here. Well, the first thing I would have to do is either bring the other terms over to this side or bring the 5x over, and then I would have to divide, so it's a few extra steps. So I would not pick that one. And the last one we're going to do that's like this, we've got x plus 7y equals 1 and y equals negative 3x plus 9. So remember, we're going to circle the one variable that is easiest to isolate out of both of them. So out of this equation and this equation, which one is easiest to isolate? This x looks pretty good because it doesn't have a coefficient in front of it. All I would have to do to isolate x is I would have to subtract 7y from both sides. So that looks pretty easy, but actually this one's even easier because this y is already isolated. I don't have to do anything to this y. So that's easiest, so I would pick this y to circle here. This is the easiest thing to isolate because it's already done. This is what the first step of our method of substitution is. That's what we're working on as our first step. You're going to always be given two equations, and you have to find the one letter that's easiest to isolate. That's your first step all the time. So let's try that out here. Solve by substitution and check. Here's our two equations, equation 1 and equation 2, already labeled for you. I've got two equations, and the first thing I want to do is which variable is easiest to isolate in either equation. If one variable is already isolated, choose that one. That's going to be the easiest. So again, here's my four choices here. 1, 2, 3, and 4. Those are all my variables. But this y is already isolated, so I don't have to do any work at all. So the first thing says, which variable is easiest to isolate in either equation? If one variable is already isolated, choose that one. And I'm going to, even though that's already underlined and everything, I'm going to still highlight it. Oops, trying to highlight it. There we go. If one variable is already isolated, choose that one. So this next step that says isolate it if necessary, we don't have, that's not necessary. This y is already isolated, so I don't have to do anything there. I'm just going to erase my blue markings there. Okay, let's look at our next step. Sub the other side of the isolated term into the other equation using brackets. Okay, so sub the other side of the isolated term. Remember, I picked this y to isolate. So the other side is this piece here. Let me just highlight that. Whoops. The other side in this case is this. That's the other side. Remember, so the other side of the isolated term. So the isolated term is the y. That's already isolated. So my next step is to take not the y, but the other side, this part, the other side, and I'm going to sub it into the other equation using brackets. So this is the kind of a main theoretical point here. If y, according to equation 2 here, y is equal to negative 4x plus 2. That's what y is equal to. These are equal. Y is equal to negative 4x plus 2. So I'm going to go over this y, and I'm going to cross it out, and instead of having a y, I already have something else that y is equal to. Y is equal to this thing right here. So I'm going to put that box part in for the y. That's a very important point that you understand what's going on here. I'm going to say that again. I already know that y is equal to negative 4x plus 2. I have that from this side. Y is equal to negative 4x plus 2. So if that's what y is, then I'm going to go to this y, and I'm going to replace it with, I know it's equal to negative 4x plus 2. So I'm going to use brackets. So I'm working with equation 1. I'll put the 1 down. I'm still working with equation 1, except instead of the y that was there, I'm going to put this box, but I'll use brackets. I'm going to put this piece here, negative 4x plus 2. I'm putting that in the place of that y. Those two are interchangeable. Plus 6 equals 2x. So this is equation 1. I took equation 1 and I substituted. That's the title of our lesson. I substituted this y with this, which is equal to y. So I put it in there. That was my step 2 here. Step 3 is to distribute and simplify. So now we're back to just a single line here. I'm going to distribute my -2 into the bracket. That's going to give, now I already have an equal sign. I'm not going to put an equal sign here because I have an equal sign over here that I'll put down later, that equal sign. One equal sign per line. So this is -8x. 2 times 2 is -4. And then the +6 equals 2x. Erase that sign there. I'm just collecting like terms. So I'm going to add 8x to both sides so that I can put my x's together. I'm on step 3 here. Collect like terms. These two are gone. And now I have -4 plus 6. Well, that's collecting like terms. Those are like terms. That makes it 2 equals 2x, and 8x is 10x. Oh, did you guys see a mistake that I made there? I see it. This is a +4 right here. Go over that right there. That was supposed to be a +4. 2 times 2 is +4. So I have to change this number to a 10. Always better to catch your mistakes sooner than later. And we all make mistakes. Now I have to isolate x. I'm going to divide both sides by 10. This is step 4. Isolate the variable. 10 divided by 10. In both cases, we get 1 equals x. Now what do I do with that? 1 equals x. So I take this answer, 1 equals x, and I sub it back into equation 1 or equation 2. It's my choice. And then solve for the other variable. Why? What am I doing? Haven't I got an answer here? I've got an answer, x is 1. Yeah, I do. But remember what we're talking about here. We're talking about where 2 lines cross. So maybe they're crossed. There's one line. There's another line. Okay, here's an x value of 1. I know they cross at an x value of 1, but what's the y value there? I don't know that. So what I have so far I know my point of intersection is 1, and then I don't know the y. That's why I'm not done, because all I have is an x, and solving means finding the point of intersection. So all I've got is the x value of the point of intersection. I don't know the other, and this graph isn't right, of course. I don't know what the graph should look like. I'm going to erase that. But what I've found so far is the x value of the point of intersection. Now I need the y value. So let's do step 5. I'm going to sub that into whichever one I choose. What equation looks easier, do you think? When you look at equation 1 and 2, which one do you want to sub into? Which one looks easier? They're both kind of the same. I'm going to sub into equation 2. So I'll just move it up here. Sub x equals 1 into equation 2. And you could pick, but I'm picking equation 2. And equation 2 is -4x plus 2 equals y. But I already know what x is. It's 1. Plus 2 equals y. So I get -4 plus 2 equals y. That's a -2 equals y. So now I know my point of intersection. So my graph before that I drew is no good. It wouldn't be like that. They're actually intersecting at 1, -2. They're intersecting right here. Whatever my 2 lines are, there, let's say that's 1, but we would pretend that's a straight line. And there is another one. They're intersecting. This is the point of intersection. So now I know the point of intersection. Step 6, statement. Remember, a solution looks like that. So your solution is a coordinate. It's not just a number. You don't just stop here and say, there's my answer, x is 1. My solution is a coordinate. Therefore, the POI, point of intersection, is 1, -2. And that is a correct answer because we solved it with algebra. We didn't solve it by trying to draw a graph and trying to guess, oh, where they cross, this is what I think. No, we solved it exactly by using algebra. Now, usually you can stop there, but I just want to show you how to go through a check. We're going to check with proper left side, right side form. So we're going to check equation 1. What are we checking? We're checking this. This is what we're checking right here. So I'll put that up here. I'm checking 1, negative 2. That's what I'm checking. This is the x, this is a y. So I go up to my original equation 1, original here, which was my, remember left side, right side means if you draw a line through the equal sign like that, this is the left side, this is the right side. So my left side is 2y plus 6, and my right side is 2x. Now I'm going to sub in with the point of intersection. So we've figured out that the y value is supposed to be a negative 2. That gives me negative 4 plus 6, and I don't know if I can fit this in at the bottom here. That's going to be a 2. Yep, okay. On the right side, I got 2x. Now x, remember, is a 1, sub in a 1, and I get 2. So left side equals right side. That means therefore 1, negative 2 is on line 1. But is it on line 2? Let's see. Let's sub it into equation. I go up to my equation 2, draw a line through here and here. This is my left side. This is my right side. My left side is negative 4x plus 2. My right side is just a y. So in for x, I put in, this is my point of intersection, here's my x, here's my y. Negative 4 times 1 plus 2. That's negative 4 plus 2, which is negative 2. And in for y, I just go ahead and sub in my y value, which is a negative 2. So that means, therefore, 1, negative 2 is on line 2. So the only conclusion we can draw, if we have one point, one coordinate, and it's on 2 different lines, it must be the point of intersection. Therefore, 1, negative 2 is the point of intersection since it is on both lines. Both lines. That makes it the point of intersection. Example 2. Solve this linear system using the method of substitution. So I haven't got all the steps written out for you this time, and I haven't got everything written out nicely. We're going to do that ourselves. We've got y equals x minus 4, y equals negative 3x plus 8. This one's easy. Y is already isolated in both equations. And we get a lot of them like this, luckily, because this is our wonderful favorite y equals mx plus b format. That's what these are. And most of the a lot of lines we work with are already in y equals mx plus b form, which means y is already isolated a lot of the times. So what was step 1 on the previous example? Hopefully you kept good notes. Step 1 said which variable is easiest to isolate in either equation, and then we're going to go ahead and isolate it. Well, y is already isolated in both ones, so I could pick whatever one I want. I'm going to pick this y here, but you could pick this one. This one's already isolated, so that was our step 1. Step 2 said this was our our new process, kind of our theoretical point. Step 2 says sub the other side of the isolated term. So this is the other side. This is what y is equal to. I'm going to sub the other side of that isolated term into the other equation. So instead of y here, I'm going to put this in its place. This is the method of substitution. I'm taking out that y and I'm subbing it in with x minus 4 because this side, equation 1, says that y is equal to x minus 4. So then I'm going to put it here. Instead of y, I'm going to use x minus 4. The reason for this is we're looking for where these two lines intersect, and they will intersect when the y is equal to each other and the x is equal to each other. So we want to know when the y's are equal to each other, so I'm going to put this y in for this y. So let's write that out. So step 2 was we sub the other side of the isolated term into the other equation using brackets. So this was my equation 1 and this was my equation 2. So I'm using my equation 2, which was y equals negative 3x minus 8, but I'm going to sub in that y. That was x minus 4. That's what's getting subbed into this spot here, which is going in for y right there. That's equal to negative 3x minus 8. Now we collect like terms. So it doesn't matter which side you bring everything over to. I'm going to collect the x's on the left. So I'm going to add 3x's here, add 3x's here. 3x and x gives me 4x minus 4 equals, these are gone, negative 8. Now I want to collect my constants, so I'm going to add 4 to both sides. 4x and these are gone, they become 0, equals negative 4. Divide both sides by 4 to isolate that x. Divide by 4 and I get x equals negative 1. So that was step 3. Step 3 said distribute and simplify. We did that. And then step 4 was isolate the variables. So we have isolated x. X is isolated. That's step 4. We're not done. It's so tempting because everything we've done in math so far says once you get an answer for x, you're done. But because we're talking about lines, lines have their point of intersection is a coordinate, and the coordinate is x, y. So we're going to take this answer and we're going to sub it into either one of these, and it doesn't matter. And if I was doing this in class, I would have half of the class sub it in here, the other half of the class sub it in here, but we would all get the same answer. So let's sub into equation 1, but it doesn't matter. We're going to sub into equation 1. Equation 1 looks a little easier, and I get to choose which one I want to sub into. So I'm going to sub into the one that looks easier. Y equals x minus 4. That's equation 1. Except instead of x, I'm going to sub in a negative 1. I don't need any brackets because there's no coefficient. We got y equals negative 5. So what I have here is therefore the point of intersection is, so you always write a coordinate with an x and a y. Our x is a negative 1, our y is a negative 5. That's the point of intersection. And you have to have a statement like that at the end. You can't just leave it like this. Or if you do leave it like this and you're telling your teacher, I don't really know what I'm doing. I just memorized a bunch of steps and I'm just doing the steps. I don't really understand this process at all. The point is that you understand a point of intersection is a coordinate. It's not just a number, it's a coordinate. So that's why you're continuing on. You're saying, I've got the x value, now I've got the y value, now I know where these two lines cross. They cross right here. So the extra step that we're not going to do this time is the check, and that's the left side, right side. And if you want to review that again, you can go back and watch the video. I'm not going to do that again here. This is the correct answer, but for sure when you're doing an evaluation, take an extra minute and do the check to make sure that you did get the right answer. Example 3, this is our last one. Bella and Frederick are renting bicycles. The charge is based on a flat rate as well as how many hours they have the bikes for. Bella rents hers from a company that charges $10 plus $2 per hour. Frederick rents his from a company that charges $6 plus $4 per hour. So remember, the charge is based on a flat rate. So to rent the bike, Bella has to pay $10 for sure. She's handing over $10 to rent the bike. But then for every hour she has it, when she comes back, she's going to have to pay another $2 for each hour that she had it. So it's a flat rate as well as how many hours they have the bikes for. Let x represent. So what is x going to represent? We need a dependent and an independent variable. You don't have to use x and y. You could use any letters you want. But x is independent, and x is usually anything to do with time. Or if you have the word per, or you have the slash for per, it's whatever comes after that, whatever comes after the per. So that's hours. So let x represent the number of hours. So that makes it easy to find out which is x, the number of hours. And let y represent, so y is the other thing. So number of hours compared to what? What else is going on in this question? Is it how many bikes? Is it how many people? No, it's the number in front of the per, which is there's a dollar sign there. So this is going to be your cost. Oops, the cost. Write an equation to represent the company that Bella rents from. Okay, let's put Bella's equation in blue. Blue for Bella. Her equation is going to be, well, her cost is going to equal, so she's paying a flat rate of $10 per hour, $10, and then she pays $2 per hour. So she's paying $10, that's a flat rate, that's a constant, plus, so I'm just taking this and I'm changing it into math, plus $2 per hour, and we used X for that. A lot of times we would have, in previous examples, you would have cost equals 10 plus 2H, where you'd use H for hours, C for cost, but for this question we're going to stick with X and Y. You can also rewrite that if you want to. You can rewrite it with the X before the 10 and have 2X plus 10. They're the same. Write an equation to represent the company that Frederick rents from. Frederick, okay? Frederick rents from a company that charges $6 plus $4 per hour. Remember, there was that flat rate, that's the $6, and then $4 per hour. So Frederick, we will use green. His cost is equal to $6 plus $4 per hour. Or you could also rewrite that with the X first, if you like. That's part C. We're on to part D. Solve the linear system by substitution. Substitution. That's all we've been doing today. Substitution. State your answer as a coordinate. Remember, always as a coordinate your answer. But this time we're also going to have a concluding sentence because it's a word problem. So I'm just going to use these equations that I used first. You could have used these as well. I've got an equation 1 and equation 2. Let me just number them. Here's my equation 1 and here's my equation 2. Remember your first step. Which variable is easiest to isolate in either equation? Well, as I said before, y is often already isolated, which makes it easier. So you just pick one of the y's, whatever one you like better. They're both already isolated, so it doesn't matter. So I'm going to pick the first one. This y is already isolated. So the rule is sub the other side of the isolated term, that's this, sub the other side of the isolated term into the other equation for y. So I'm going to put my box around this one here. This is all equal to y. So I'm going to put it in for this y right here. I'm going to substitute right there. So my new equation 2 is now going to be, instead of y, I'm putting 10 plus 2x. And then that's equal to the other side, which is 6 plus 4x. Well, first I'm going to collect my x's, subtract 2x from both sides. That gives me 10, these are gone, equals 6 plus 2x. Now I'm going to subtract 6 from both sides to collect the constants. So I'm on step 3, which is distribute, simplify, collect like terms. This gives me 4 equals 2x. Almost isolated. Step 4 is isolate the variable. So I have one step left to isolate the variable, and my last step is divide both sides by 2 so that these 2's cancel out. Now I've isolated x, and I've got x equals 2. Remember, you're not done. The question said state your answer as a coordinate. All I know so far is that x is 2, but what does that mean, x is 2? Remember, x was a number of hours. So now I know 2 hours, something about 2 hours. What exactly is going on at 2 hours? Well, let's finish the question and then we'll put it all together. So the next step, step 5, is to sub your answer, that's the 2, x equals 2, back into either one of these, your choice. Let's take equation 2 this time. So I'm going to sub x equals 2 into equation 2. That the original equation, as it was originally, not after I substituted or anything, was 6 plus 4x. So I'm putting the 2 in for x. I get y equals 6 plus 8. So y is 14. Okay, so I've got my point of intersection. State your answer as a coordinate. Let's do that first. Therefore, point of intersection is the x value was a 2, the y value was a 14. So that's stating it as a coordinate, but what about the concluding sentence? So what does all of this mean? Remember I said this is, since x is hours, this is 2 hours, so that's 2 hours. Y is cost, so that's $14. So what does this mean? 2 hours, $14. What's going on there? What does this mean? 2 hours, $14. Remember what we're looking for is the point of intersection. So we have found where the cost of Bella's bike and the cost of Frederick's bike intersect. So if whatever company they decide to rent from, if they only rent their bikes for 2 hours, both of them rent their bikes for 2 hours, they're both going to pay $14. That is the one place where the cost will be the same. The cost and the time are the same. Now, if you look down to part B, what if they rent it for 3 hours? Well, we'll talk about that. But if they rent the bike for 2 hours, they will pay $14 no matter which company they rent from. That's what the point of intersection is saying. It's where everything is equal. Point of intersection is 214. So at either bike rental company, either one, renting for exactly 2 hours will cost the same amount, $14. That's what this point means. So if they're only going to use their bikes for 2 hours, then it doesn't matter where they rent their bikes from. But what if they're going to rent their bikes for 3 hours? Which company is better to rent from? Well, the better company would be the cheaper company. So I want to know if they rent the bikes for 3 hours, which one is cheaper? So remember this, 3 hours, that's an x value. X is the number of hours. So I'm going to go to each of these equations here. Erase this line here. I'm going to go to my equation 1 and my equation 2 original, and I'm going to sub the 3 in for x. So equation 1, that was in blue, so let's do that. Equation 1, it's going to be crowded though. Equation 1 was y equals 10 plus 2x, but instead of x, I'm putting a 3 because remember, hours is our x value. That's y equals 10 plus 6, so that's $16 if they go with Bella's company. What if they go with Frederick's company? So Frederick's company was equation 2, and that equation was y equals 6 plus 4 times x, but instead of x, we're checking out the value of 3. So that's 6 plus 12. So that one is going to be $18. So if Bella and Frederick know in advance, they already know, well, we're going to have the bikes for 3 hours. They already know that. They're going to do their math and they're going to rent from the cheaper company. So which company is better to rent from? If they're renting the bikes for 3 hours, then the cheaper company is the one that Bella chose. Therefore, if they rent bikes for 3 hours, Bella's company is better, and that's because it's cheaper. So that is a practical example of why we need to find points of intersection. And there's a lot. This is probably one of the most practical applications of anything we're going to do possibly this year, is finding points of intersection, which means finding solutions, solving linear systems by substitution.